Problem 4 here in a very predictable part A. They ask a question like this every year, and so it's pretty obvious what we're going to do. We're going to say that h prime of 6 is approximated by h of 7 minus h of 5 divided by 7 minus 5, so divided by 7 minus 5, and so this is going to say 11 minus 6 divided by 2, which is 5 divided by 2, or 2.5, and the units are meters per year. And the interpretation is that at year 6, the tree is growing at a rate approximately equal to 5 over 2, or 2.5 meters per year. Yeah? Okay, cool. So there that is, and that's part A. So let's move on to part B. What does part B say? Part B says this, which is, it says, explain why there must be at least one time t from year 2 to year 10 so that h prime of t is equal to 2. And if you look carefully at the table, you will see that h of 5 minus h of 3 divided by 5 minus 3 is equal to h of 5 is 6 and h of 3 is 2. So it's equal to 6 minus 2 divided by, and then it's 5 minus 3 is 2. So that's 4 divided by 2, or equal to 2. So since we have the average rate of change in tree height, right, from year 3 to year 5 is equal to 2 by the mean value theorem, so MVT, by the mean value theorem, we know that there must be a time t where this average rate of change is equal to an instantaneous rate of change for a time between 3 and 5, and therefore for a time between 2 and 10. So we know that this has to equal h prime of t. So we see that h prime of t will have to equal 2. For some value specifically between 3 and 5, t equals 3 and 5 from what we can see from what's given in the table, maybe elsewhere, but definitely between 3 and 5, and therefore between 2 and 10. Yeah? Okay, cool. So let's keep it moving, and next is part C. So part C says this, and this is probably like where I'm going to spend most of my work. So use a trapezoidal sum with 4 subintervals, and the subintervals are like 2 to 3 is our first interval, right? 2 to 3 is our first interval, and then the next interval is 3 to 5, and the next interval after that, figure not drawn to scale with this mark here. Next interval is 5 to 7, and okay, and then finally 7 to 10. Right? These are the subintervals, the 4 subintervals suggested by the table. So 7 to 10. Okay, let's make this one a bit more convincing. There we are. Now, remember, the length of each interval is going to be the height of the trapezoid. I'm not going to explain it any more than that. And so the height of our first trapezoid will be 1, 3 minus 2. The next trapezoid is 2, and then the one after is 2, and then the third and final trapezoid is 3. Now, the question here is asking us to approximate the average height of the tree. So this is an average value question. We know that the average value of a certain function is over an interval AB, right? So in this case for h is going to be given by 1 over b minus a times the integral from a to b of h of t dt. So that in our situation will say 1 over 10 minus 2. So a is 2 and b is 10. So that's 1 over 8 times the integral from 2 to 10 of h of t dt. Now, the subintervals and the trapezoid obviously comes into helping us with this integral, right? Approximating that integral. So I'll circle this integral in blue and find the calculation that will give us the answer to it, and also in blue. So I already started. We found the height of our trapezoids. And so what we need to do is find the average of the bases for each trapezoid, and then multiply by the height, and then add up the area of the 4 trapezoids. So for the first one, we'll have to say h of 2 plus h of 3 divided by 2. So this divided by 2, and then the height, so this is the average of the bases. The height is 1, so I won't even bother multiplying by 1. And then the next trapezoid will have area equal to h of 3 plus h of 5 divided by 2, and then times the height, which is 2 this time, so divided by 2, and then times 2. Yeah, okay. We obviously need more space, so I will shift this to the left like that. That'll work. Plenty of space. And then plus the next trapezoid will be h of 5 plus h of 7 divided by 2, and then times, this is the average of bases for that trapezoid, and then times 2, and then finally plus, and this is all just to approximate that integral, and plus finally we'll write h of 7 plus h of 10 divided by 2, and then times 3, right? Okay, cool. Now let's find each of these. So h of 2 plus h of 3 is 1.5 plus 2, so that's 3.5. So that's 3.5, so I'll start with this guy. So we have equal, just the integral part, equals 3.5, and that's the numerator. H of 2 plus h of 3 is 3.5, and then we need to divide that by 2. 3.5 is 7 halves, and so when we divide that by 2, it's going to be 7/4. So I'll just write 7/4. So all of this right here is 7/4. And then we'll have plus what? H of 3 is 2, and then h of 5 is 6. When we add them, we get 8. When we divide that by 2, we get 4, and times 2 is going to say 8. So our second trapezoid will have area 8, and then plus. Our third trapezoid, h of 5, and then h of 7 added, that will make 17. 17 divided by 2, and then times 2 is just 17. And then finally plus. H of 7, 11 plus 15 is 26 divided by 2. That's that. So that's 13 times 3 is 39, right? Okay, 39. There we are. And now I do not need this junk, so let me get rid of it. Definitely need the space. Okay, so what is this sum? This sum is equal to 7/4 plus 8 plus 16 plus 1 plus 39, and therefore plus 40. And these guys combine to 24, so that will be 7/4 plus 24 plus 40, so that's 64. So instead of writing plus 24 plus 40, let me just write 64, right? Okay, cool. And now if I do 64 times 4, that'll be 60 plus 4 times 4, right? That's 64 times 4. So 60 times 4 is 240, and then plus 16 is, what's that, 256? So we can write this as 256 over 4. So we've got 7 over 4 plus 256 over 4 is equal to 263 over 4. Now 263 over 4 is what I've circled here. So we still need to multiply by an eighth. So when we do, it's obvious that our final answer is going to have to be, so everything including multiplying by the 1/8 is going to be 263 divided by 32, right? The 1/8 multiplying the 1/4 times 263, that's in there. Yeah, okay. So there it is, and this is part C. All right, so let's move to our final part, and that's part D, right? Okay. So part D. Part D says this. Ooh, can I erase this thing from part C? I don't think so. I got to go back to the part C slide. Okay. All right, that's better. So part D. Part D says a lot of stuff. So basically it's saying ignore the table and let this be the height. And so we have an actual function instead of just selected values of the height, right? Okay, so fine. And then what? When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03, and the diameter is called x. So basically, this is a related rates question. We have dx dt. Dx dt is equal to 0.03 meters per year. When the tree is 50 meters tall. And remember, the height of the tree this time is given by g. So we know dx dt is equal to 0.03 meters per year when g is equal to 50. Got it. And what is it asking for? It's saying, according to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when it's 50 meters tall? So basically it's asking for dg dt when g is equal to 50. Now, notice first that dg dt is equal to, dg dx times dx dt. And we know what dx dt is when g is 50. Not when t is 50, but when g is 50. So we know dx dt when g is 50. And, oh, what is that? I wrote g is equal to 0. So when g is 50, I don't want to run out of space. So we know dx dt when g is 50, and it's equal to that. Okay. And we need to then know what dg dx is when g is 50. So we need to evaluate this also when g is 50. And if we do, then we'll be able to figure out what dg dt is when g is 50, right? Okay, cool. So g is 50. So it looks like all we have left to figure out is what this guy is right here. And once we know what that is, we'll just multiply it by 0.03 and we'll be able to find dg dt. Okay, dg dx will have to be the following since g of x is given by that. Using the quotient rule, dg dx or g prime, right? dg dx is g prime, right? And that's going to equal, by the quotient rule, derivative of that, which is 100, times the bottom, which is 1 plus x, and then minus the top, which is 100x, and then divided by, the top and then 100x times the derivative of the bottom, which is 1, which is, I guess, why I rushed to divided by, because the derivative of this is just 1, right? Okay, and so I won't even bother writing it. So then divided by what? Divided by the bottom squared, right? And I just applied the quotient rule, and the bottom squared is 1 plus x squared. All I did is apply the quotient rule on that to find g prime, which is what dg dx is. But look, we need to find dg dx when g is 50, but dg dx is a function of x, right? And so how do we find x corresponding to g equals 50? Well, simple. Since g is given by that equation, when g is 50, we'll have 50 is equal to 100x divided by 100x divided by 1 plus x. And by cross multiplying, we can get, writing this over 1 and cross multiplying, we can get that 100x is equal to 50 times 1 plus x, and we can write that as 50 plus 50x. From this, we see, subtracting 50x from both sides of this equation, that we've got that this means 50x is equal to 50, so x is equal to 1. So when g is 50, x is equal to 1. So to figure out dg dx when g is 50, we just need to evaluate this when x is equal to 1. Yeah? Okay, cool. That should be clear. So when x is equal to 1, let me undo. It took my writing. Did you see that? Okay, with it. Okay, so I need to be a bit more careful. All right, so there it is. So we evaluate this at x equals 1, and when we do, we get, and so this will be like x equals 1, but it's equivalent to g equals 50, right? X equals 1 is equivalent to g equals 50. And so when x is 1, we have 100 times 1 plus 1, so 200, and then minus 100 times 1, so minus 100. And then this divided by, and then the denominator is 1 plus 1 squared, so 4. And clearly this is going to be 25, right? So we've got that this here, which is what we've been after, is equal to, we just learned that this is 25. So we've got 25, and then times, and then we know that this here is equal to that there. It was given at the start, right? So times 0.03, and this is meters per year. So when we multiply, we get 0.75 meters per year. Yeah? Okay, cool. All right, this concludes the solution to 4, and keep watching. Take care.